Introduction to atoms, molecules, mole and molar volume. Let's start with the basic in chemistry, the foundation. By definition, chemistry is the study of matter and the changes it undergo, whether it involves things that we can see, such as water, and things that we cannot see, like oxygen molecule. Because of its diversity, it's often called as central science, where it connects other branches of sciences such as physics and biology. The theories in chemistry are obtained mainly from experiments conducted from years before and still developing. So, chemistry is a study of matter. What is matter? Matter is anything that occupies space, which means it has volume and has mass. Matter can be subcategorized to pure substances and mixtures. Pure substances can be subdivided into compounds that include molecules, which is substance with definite atom proportion connected by chemical bonds, and ions, which are atoms or group of atoms with charges. We also have elements, mainly include metals, nonmetals, metalloid, and transition metals. On the other hand, mixtures are subdivided into homogeneous mixture, or commonly known as solution, where two or more substances mix. Each substance cannot be differentiated, like when we're dissolving salt in water. Once dissolved, we cannot pinpoint which is water, which is salt. The other type of mixture is heterogeneous mixture. This type of mixture is when we're able to differentiate the substances, such as adding sand to water. We're able to pinpoint which is water, which is sand, because sand simply doesn't dissolve in water. Molecules are divided into diatomic molecule, where it contains two atoms connected by a chemical bond, such as oxygen gas, O2, or carbon monoxide, C double bond O. While polyatomic molecules are molecules with more than two atoms connected by a chemical bond, such as water, H2O. There can be two charges of ions, either positive charge called cation or negative charge called anion. And these ions can appear as monoatomic ions, such as hydrogen ion H+, or polyatomic ions, such as hydroxide ion OH negative. There are three basic states of matter can appear as, which are solid, like ice, or liquid, such as water, and gas, such as oxygen gas. They can react to undergo physical or chemical changes. So physical changes are observed when the identity of the substance remains the same. For example, liquid water evaporates to become water vapor. The beginning and ending substance remain the same, which is H2O, just the state is different, starting as a liquid and end as a gas. While chemical changes happens when the substance loses its identity once the reaction finishes. For example, electrolysis of water changes H2O, the initial substance, into hydrogen gas H2 and oxygen gas O2. Relative masses of atoms and molecules. Each element listed in the periodic table has its own isotopes. So isotopes are atoms of the same element with the same number of protons and electrons, but with different number of neutrons. For example, hydrogen atom has 3 isotopes. The most abundant isotope, hydrogen 1, with 1 proton, no neutron. Deuterium, 1 proton and 1 neutron, and tritium, 1 proton and 2 neutrons. Definitely, these isotopes has different mass because the mass of an atom is contributed by the number of protons and neutrons in it. And these masses are called relative isotopic mass. And when we combine all of these isotopic mass and compare to the mass of carbon-12 isotope, we will have the relative atomic mass of the element. These masses are the mass written in the periodic table. The mass of element is calculated to compare to the mass of carbon-12 isotope as a reference mass. So this is the definition and how to calculate. Let's go into this example. Naturally occurring chlorine is 75% of chlorine 35 and 25% of chlorine 37. Calculate the relative atomic mass. First, calculate the average mass of both of the chlorine isotopes. So we have 75% of 35 chlorine plus 25% of chlorine 37 and divide by 100 to convert into non-percentage. So we have 35.5. And then we will compare the mass to carbon-12 isotopes. Therefore, we will have the mass of chlorine as 35.5 AMU. This is the unit for relative atomic mass. For any molecule, the relative molecular mass is calculated by adding all of the atoms' relative atomic masses together. While for ionic compound, the sum of addition of its relative atomic mass is called relative formula mass. And definitely the mass of any substance is compared to the mass of carbon-12 isotope as a reference mass. So let's get into this example. Calculate the relative molecular mass of CO2. So just add the mass of carbon and oxygen together. Since we have 2 oxygen, therefore multiply the mass of oxygen by 2, therefore we have 44. And this is an example of ionic compound. Calculate the relative formula mass of NaCl. So just add the mass of Na and Cl together. We will have 58.5. But how did the chemists get all of the isotopes' mass and its abundancy? They actually got it along with the information through a method called mass spectrometry, and the instrument is called as mass spectrometer. In short, we will just call it mass spec. Mass spec is a very sensitive and powerful method that can provide data as, but not limited to deduce how many isotopes the element has, to deduce the mass and abundancy of each of the isotope to obtain the relative mass of the element, and also to deduce the mass of molecules. So how does mass spec work? We start with injecting the substance into the machine, which it will be turned into ions. The ions then move along through the machine with the help of electric field. Then the ions enter a velocity selector to ensure the ions at different mass travel at the same speed. Imagine it like in a race competition, all competitors must have the same starting point to make the race valid. Then under magnetic field, the ion will be deflected based on its mass. The heavier ion will be deflected less than the lighter ion, which make the lighter ion to reach the detector first, followed by heavier ions. The mass and how many of the ion is recorded, which will be represented in a graph called mass spectrum. Mass spectrum contains relative abundance at the y-axis, which show how many of that ion is present, and M/Z ratio, which shows the mass of the ions. And since most of the ions formed have a single charge, so the M/Z ratio is equivalent to the mass itself. This is the mass spectrum of chlorine. From here, we can see that chlorine has 2 isotopes, one with a mass of 35 and the other is with mass of 37. Chlorine 35 is the most abundant isotope, occupies 75% of the total isotope in chlorine, and the remaining 25% is chlorine 37 isotope. Does this information seems familiar? Yes, the example we did earlier, the information is from this mass spectrum. Another example of a mass spectrum is mass spectrum of iron. So from here we can see that iron has 4 isotopes at 54, 56, 57, and 58 M/Z ratio. The most abundant isotope is iron 56, followed by iron 54, iron 57, and iron 58. The amount of substance. How many chemical species in a substance is calculated through mole. By definition, a mole of any substance is the number of particles as that is exactly in carbon-12 isotopes. From further studies, it shows that 1 mole of any substance contains 6.02 multiplied 10 to the power of 23 particles in it. It is called as Avogadro constant, and it applies to any substance, be it molecule, atoms, ions, or compound. Example: how many atoms are there in 2 mole of silver? Since a mole has 6.02 multiplied 10 to the power of 23 particles, then 2 mole must contain 1.2 multiplied 10 to the power of 24 particles. So how do we get the mole of any substance? This is a mole triangle. where mole of any substance is equivalent to mass of the substance divided by its molar mass. Let's do this example. A student plans an experiment that uses 0.2 mole of calcium phosphate. How many grams of calcium phosphate need to be weighed? First, calculate the molar mass of calcium phosphate by adding all of the individual masses of calcium, phosphorus, and oxygen. Then, insert inside the mole equation, we have the mole, which is 0.2 mole. The mass is what we want, and the molar mass has been calculated. Therefore, we can get the mass equivalent to 62.1 gram. So, for gases at standard temperature and pressure, the mole is equivalent to its volume divided by molar volume. And the molar volume of any gas at STP is constant at 24 dm³. Let's go into this example. Calculate the volume of 0.21 mole of helium gas at STP. So just insert inside the equation. So we have the mole, we have the molar volume, hence we can calculate the volume as 5.04 dm³.